Recording.
Hey guys, sorry it's so dark on here. It's late at night. I finally have a chance to get this done. So we are learning about volumes. This entire chapter we're going to be doing volumes. Today are going to be doing prisms and cylinders. So yesterday you identified prisms and cylinders, especially prisms. You were able to find their bases. Remember, bases of prisms are two shapes that are parallel to each other, connected probably by rectangles. So you're going to find those two shapes. Before we begin, we've got some things to define. So volume is the amount a shape takes up space. It's amount of space a shape takes. And I don't have my geometry book in front of me, so that is me paraphrasing, but it's definitely the amount of space that it takes up. Our volume of a cube postulate, if this side is S, whatever it would be, remember a cube, all of those sides are the same. So my height would be S and my base would be S. So it'd be S cubed. Multiply them together. Now we're not going to use that a ton, especially because it's the same. You'd use the same thing if you just looked at it as a square prism. So that's what we're going to do from now on. We have volume congruence postulate. It says if two polyhedra are congruent, then their volumes are congruent. And that should make sense to you, that if they're congruent, then their volumes have to be the same. They're taking up the same amount of space. Volume addition postulate, we'll be working with that a little bit today. And it's the volume of a solid is the sum of the volumes of the non-overlapping parts. So we're going to have to break some shapes down into multiple parts so that we can then find the volumes. All right, now we're getting to the good stuff though. Volume of a prism. So the volume of a prism is our base, the area of our base times the height. So we have the area of the base and then we have the height. Now here's the key to this entire thing is height is always, notice, I am writing that in all caps, probably important. It's always perpendicular. So whenever we're looking for the height of any prism or any cylinder, we are always making sure that that height is always perpendicular. The volume of a cylinder, again, we're going to find the area of the base. Those bases, that's the area of a circle. And so the volume of a cylinder is the area of the base times the height, or pi r squared, that's the area of the base, times the height. Again, height is always perpendicular. So we're going to practice with some very simple ones. Should be very easy for us to do. The first one is a right triangular prism. Now, that triangular prism, remember, we are looking for the two shapes that are exactly the same and parallel to each other. So what you're going to notice is I've got two triangles here that are exactly the same and they're parallel to each other. Then you should see lots of other rectangles. There's always going to be rectangles and prisms. The key to this is to find the two shapes that are exactly the same, parallel to each other. So these are my bases. So the area of this base is 1 foot times 3 foot, or 3 foot squared. And then we have to multiply it times the height because volume is base times height. So it's going to be 3. Oh, and I forgot my 1/2. I'm so sorry. It's a triangle, so it's 1/2. So that is 1.5 feet squared. I'm positive all of you figured that out before I did. It's 1.5 feet squared. So the area of that base is 1.5 times the height. The height is the distance between those two bases, 2 feet. So my volume of this right triangular prism is 3 feet cubed. Now, we're going to move on to the cylinder. Because it's telling us it's a right cylinder, right triangular prism, right rectangular prism, that means currently my height is perpendicular. So That's what that means. And then we don't have to find our height. We'll be able to do that later. So in order to find the area of, or the volume of this cylinder, up top, we see that it is pi r squared times our height, the area of our base times our height. So my volume is pi r squared, r is 5, so r squared is 25 times my height, which is 6. So I'm going to leave it in terms of pi, and we're able to do that most times. That means my volume is 25, which is my r squared, times my height. I'm multiplying those two. I get 150 pi meters cubed. Don't forget your units, and don't forget that they're cubed. The last one, a right triangular prism. Again, because, or rectangular, because it says that it's right, we know that everything is perpendicular. So this one's super simple, that we're able to just multiply our base times our length times our width times our height is probably what you learned in 7th grade. So our volume is length times width times height. And I'm just putting that into my calculator. And I get 220 meters cubed. All right. So that should have been really simple for you guys to see, other than my mistake, that area of a triangle is 1/2 base times height, which I threw in there. Let's flip the page. Now, example 2 gets to be a little more fun because we know that the volume of a right cylinder is base times height, or because we know that it is, we know that the area of a circle is pi r squared. We know that it is pi r squared height. So now they've given me the volume, 1253, and I'm going to fill in all the things I know. I have pi r squared, and then I don't, and I have my height, which is 10. So we're going to solve for r. We're going to divide by 10. We're going to divide by pi. We're just going to use 3.14 for pi. So I am going to divide this by 31.4. 3.14 times 10 is 31.4. So I'm dividing by those. If I do it to one side, I have to do it to the other side. So that means r squared is equal to 1253 divided by 31.4 is 39.9. Now that's my r squared. So in order to get r, I'm going to have to take the square root of both of those. So the square root of 39.9, that means r is equal to 6.3. 6.32 if we're going to be exact. And that is in centimeters. You guys are going to do the next one. Notice that the next one, we are looking for the diameter, not the radius. You're going to push pause. You're going to work on example 3, and then we're going to come back and you're going to check your answer against mine. All right, so check your answer against mine. I've written everything out so that you can check and make sure that you've got the right thing. Unlike when I'm there and I just give you the answer, here we need to make sure that we understand everything that's going on. Check your answer. If you don't all agree, then push pause, have a class discussion on this. We're going to move on to Cavalier's principle. Now, what Cavalier's principle says is that essentially, if two prisms or two solid things have the same height, remember height is always perpendicular. If they have the same height and the same cross section, so when we look at it, they're both circles, ovals, rectangles, anything like that, then they're going to have the same volume. So here, what we're going to do for the next two is we're going to look and notice that that one of them I am given my height here. Height always perpendicular, and I just get to use that. In B, I have to find my height. Thank goodness they give me a 30, 60, 90 triangle, and then I can solve for it. So A, we are going to say that our volume is always my base times my height, and my volume is equal to pi r squared, r being 5, so that's 25. 5 times 5 is 25, times my height, height always perpendicular to the base. So my volume is equal to 200 pi inches cubed. Don't forget the volume's in inches cubed. We've multiplied to get to inches cubed. Now, let's look at B. B, we're going to have to find. All right, guys, I had to push pause to blow my nose. All right, so we have to find our height. Now, what we're going to notice is that we've got a 30, 60, 90 triangle, and it's a right triangle. We love right triangles. And if this side is 18, then this side is 18. So I know my hypotenuse. So I can now find everything else. We're not going to use sine, tangent, and cosine because we're way smarter than that. We're going to use our 30, 60, 90 triangle. So if this is 18, my hypotenuse is 18, then that means my short side across from 30 is half of 18, 9. And that means my height is going to be 9 square roots of 3. We take our 9 and we multiply it by the square root of 3. Now, they've given me my diameter, which means that my radius is half of that, or 6. So I've got everything I need now. I know that volume is equal to base times height, the area of my base. That means my volume is equal to pi r squared times my height. And I've been given my r is 6, so my r squared is 36, and my height is 9 square roots of 3. Now remember, when we're working with square roots of 3, or square roots, you can only do something with a square root if it's being multiplied by a square root. Because it's not, we're just going to multiply 36 times 9 so that I get that my volume is 324 square roots 3 pi millimeters cubed. Sorry, I ran out of room. So that's where we are so far. We've worked on oblique cylinders. If you have an oblique prism, it's the same thing. You're going to find your height. You know how to do this. Sine, cosine, tangent, 30, 60, 90 triangles, 45, 45, 90 triangles. And then you know how to find the rest. The last thing we're going to do is we're going to find the volume of each solid. Now, what this is showing us is that we have a portion of this cylinder that's been taken out, a second cylinder. So we're going to find one cylinder, we're going to find the other, we're going to subtract them. Let's do that. First cylinder, we're going to say volume of the first cylinder is equal to my base, which we know as pi r squared. My r is 3, so 3 squared is 9, times my height, 7. So I have 63 pi millimeters cubed. Now I have to subtract volume of the second one. It shows me that my radius is 1 millimeter. So my volume of my second one is pi r squared. 1 times 1 is 1, times the height, which is 7. So that is 7 pi millimeters cubed. I'm going to subtract them. V1 minus V2 is going to be 63 pi minus 7 pi. And that's going to give me 56 pi millimeters cubed. Now it's really difficult when I'm doing this without you to know if I'm going too fast, too slow. Have the teacher pause it if I'm going too slow or too fast for you. If I'm going too slow, well, that's not a surprise. You guys are crazy smart. Let's look at B, our last example. So we've gone through not a ton of examples, but you guys have homework that is due tomorrow that you will work on in class. Again, ask anybody and I can always help you tomorrow morning, but you are going to make a productive struggle. Make sure you know what you're doing. So what we're going to do for the second one, what you should see is that you have a cube and you have half a cylinder. So this is going to be my V2, and I've got V1. My volume of the first cylinder is a cube, so it's just going to be 4 times 4 times 4, which is 64 inches cubed. Because it's a cube, I just did length times width times height. Now, the volume of the second one, I have to find, I know, is base times height, which I know is pi r squared times height. But it has to be half of it because it's only half a cylinder. So now we're able to put everything that we know in. Our radius is going to be half of 4 because it can only go half the distance. So that's going to be 2. 2 squared is 4. And my height, the length that this goes, is also 4. 4 times 4 is 16 divided by 2. I get 8 pi. And that's in inches cubed. So the volume total, I'm just going to add them together. I've got 64 plus 8 pi inches cubed. Notice that I can leave them just like this. I can't add them together unless I were to multiply by pi. Pi is a number. We can't just add them together willy-nilly. All right, so I miss you all. I'd rather be with you. I hope you have a fantastic day, and I will see you on Friday.